Very well. In 7.5, we're going to talk about hypothesis tests for variance and standard deviation. So far we learned that how to use z-table, t-table. We learned about normal distribution, t-distribution. Today we're going to talk about chi-squared test. In real life, it's important to produce consistent, predictable results. For instance, consider a company that manufactures golf balls. The manufacturer must produce millions of golf balls, each having the same size and the same weight. There is a very low tolerance for variation. Low tolerance for variation. For a normally distributed population, we can test the variance and standard deviation of the process using chi-square distribution with n-1 degrees of freedom. Before learning how to do the test, you must know how to find the critical values. Very well. Let's take a look at the guidelines. Finding critical values for a chi-squared test. First, specify the level of significance, which is alpha. Then, identify the degrees of freedom, which is n-1. Remember that n is your sample size. The critical values for the chi-square distribution can be found using chi-square table. So if you have a right-tailed hypothesis test, it means that if your rejection region is on the right-hand side, or if you want to form your null alternative hypothesis, here you are working with variance or standard deviation. So suppose we are working with standard deviation. Standard deviation is greater than k. So it's opposite, null hypothesis. Standard deviation is less than or equals to k. Because your alternative hypothesis is greater than, there is no equality here, so it is alternative hypothesis, you shade right-hand side. And you have right-tailed graph. In this case, to find critical value, use the value that corresponds to degrees of freedom and alpha. You don't have to do any algebra. Guys, remember when it comes to z-table, you had to do a little bit of algebra, finding the value, the area, then 100% minus the area. Here you are using chi-square test. It's different from z-table. You're using chi-square table. You don't have to do any algebra when it comes to right-tailed test. But if you have a left-tailed test, if your rejection region is on the left-hand side, you have to do a little bit of algebra. After finding the critical value using the chi-square test, you have to subtract alpha from 1. And finally, if you have a two-tailed test, to find the critical value, you have to divide alpha by 2 and 1 minus alpha by 2. So you're finding 2 separate values, and then you use your table. Let us go over one example to see what's going on. Question says, find the critical value for a right-tailed test. What's given? Sample size is given, it's 26. What's alpha? Alpha is 10%. So we're going to use chi-square table. I'm going to show you how to use the chi-square table, but it's the exact same process. The degrees of freedom is going to be on the left-hand side, the first column, 26, and your alpha, which is 10%, is going to be on the first row. The intersection between these two is going to be your critical value, which is equal to 34.382. When you go to your canvas, you can see chi-square table 6, which is the same table that I'm going to use for our class. Okay. Here we go. This is our table. So in this example, degrees of freedom is 25 and alpha is 10%. So 25, and alpha is 10%. So the intersection between these two gives you the critical value, which is 34.382. Chi-square table, degrees of freedom is 25, alpha is 10%. You have a right-tailed graph, and the intersection between these two gives you critical value, which is equal to 34.382. Very well. Perfect. Let us move on to next example. So far we talked about right-tailed graph. Now we have a left-tailed graph. So suppose n, or sample size, is equal to 11 and alpha is just 1%. We're going to find the critical value. First of all, we find the degree of freedom, which is 11 minus 1, 10. Alpha is equal to 1%. Remember that since you have a left-tailed graph, you have to do a little bit of algebra before finding your critical value. 1 minus alpha is 1 minus 1%, or 99%. Now we look at the table. Degrees of freedom, 10, and 1 minus alpha is 99%. The intersection between these two gives you your critical value, which is 2.558. Let's take a look at our table. 10 and 99%. 2.558. That's your critical value. Very well. What if we have a two-tailed graph? Here you have to do a little bit of algebra. N, or sample size, is given as 9. Your alpha is 5. And the question says you have a two-tailed test. First, let us find the degrees of freedom, which is n minus 1. 9 minus 1 equals to 8. First, divide alpha by 2. 5% over 2, which is 0.025. Look at your table. Degrees of freedom is 9 minus 1, or 8, and the first level of significance is 0.025. Find the intersection between these two. Then 1 minus alpha over 2, which is 0.975. Find the intersection between 8 and 0.975. So you're going to find two critical values because you have a two-tailed graph. We expect to get two different critical values. Very well, let us take a look at the table. 8 and 0.025. So let me erase these two. Eight 0.025, the intersection between these two gives you 17.535. Now 1 minus a half alpha gives you 0.975. 0.975. The intersection between these two gives you 2.180. You have two critical values. 2.180 on the left-hand side and 17.535, which is critical value on the right-hand side. Very well. So how do we use a chi-square distribution to analyze our hypothesis test? First of all, as you always know, you need to find a test statistic. When you have S squared, it means that you have sample variance. S squared is sample variance. Note that chi-squared or test statistic is equal to n-1 times S squared sample variance divided by sigma squared, which is population variance. Population variance. So guidelines, first, you need to verify that the sample is random and population is normally distributed. Then you need to form your null alternative hypothesis, identify your alpha, level of significance, find degrees of freedom, n-1. Then you need to find your critical value or critical values using chi-square table. Then you need to determine the rejection region or rejection regions. Find your test statistic, chi-squared equals to n-1 S squared over sigma squared. And finally, make a decision if to reject or fail to reject the null. Example, using a hypothesis test for population variance. Population variance, sigma squared. So suppose you have a company, it claims that the variance of the amount of fat in the whole milk processed by the company is no more than, okay, 0.25. So what's the meaning of that? No more than, it means that you have less than or equal to. No more than is less than or equal to. That's the meaning of no more than. So what's given? Your null hypothesis is given. It says your variance, sigma squared, is less than or equal to 0.25. So now you can form your alternative hypothesis. Sigma squared is greater than 0.25, and note that the claim is your null hypothesis. Okay, you suspect this is wrong and find the random sample of 41 milk containers. 41 is your N sample size, which has a variance 0.27. This is your variance of the sample, which is S squared. Suppose your alpha level of significance is just 5%. Now you need to decide if to reject or fail to reject the null hypothesis, which in this case is your claim. Okay. The graph is a right-tailed graph because your alternative hypothesis is greater than. Since it's greater than, we don't do any specific algebra. The degrees of freedom is equal to 40, and your alpha is 5%. Since we are working with variance, we have to use chi-square table. We find the intersection between these two in chi-square table, and we find critical value to be 55.758. You have a right-tailed graph, and the critical value is 55.758. The rejection region is on the right-hand side. On the left-hand side, you have a non-rejection region. Perfect. Next step is to find standardized test statistic. Chi-squared is n-1, S squared over sigma squared. 41 minus 1 times 0.27 divided by 0.25, which gives you 43.2. 43.2 is less than 55. It's outside the rejection region. It means that you fail to reject the null hypothesis, which in this case is your claim. So you can interpret it this way. There is not enough evidence at 5% level of significance to reject the company's claim. Let us move on to next example. You have another company that claims that the standard deviation, guys, this is different from previous example. Now you have standard deviation, which is just sigma of the length of time it takes an incoming telephone call to be transferred to the correct office is less than 1.4 minutes. Very well. So what do we have? We have less than. It means that our alternative hypothesis is given, and it says sigma is less than 1.4. So it's opposite. Alternative hypothesis is less than. Null hypothesis says sigma is greater than or equals to 1.4. It means that you have a left-tailed graph, and since you are working with standard deviation, you have to use chi-square value. So we need chi-square table, and we have to do a little bit of algebra. Okay. A random sample of 25 incoming telephone calls. So n is given, n is 25, has standard deviation 1.1. This is standard deviation of the sample. And your alpha is 10%. Since alpha is 10%, first you have to do a little bit of algebra. 1 minus 10% gives you 90%. Now you use your chi-square table, 90%, and degrees of freedom is 24. Now you find the intersection between these two, and you get your critical value to be 15 15.659. So the rejection region is on the left-hand side, and the dividing number is your critical value, 15.659. Now we find the standardized test statistic, chi-squared, which is n-1 s squared over sigma squared, 25 minus 1, 1.1 squared divided by 1.4 squared, and you get 14.816. Since 14 is less than 15, it means that your test statistic is inside the rejection region. What's the meaning of that? It means that you reject the null hypothesis. So remember that the claim is alternative hypothesis because the company claims that it's less than. So your alternative hypothesis is your claim. How do you interpret that? There is enough evidence at 10% level of significance to support the claim. Example, then we're going to have our break. Perfect. So, sporting goods manufacturer claims that the variance, okay, variance sigma squared of the strength of a certain fishing line is 15.9. So keyword is. So what's given? Your null hypothesis is given. In this question, you have your null hypothesis. Its opposite, alternative hypothesis, says sigma squared or variance of the population is not 15.9. So you get a two-tailed graph. Two-tailed graph. Okay, you have a sample random sample of 15 fishing lines. So you have your n, and the variance of the sample is 21.8. So S squared is also given. Your alpha is 5%. Now check to see if you have to reject or fail to reject the null hypothesis. Note that your claim is the same as your null hypothesis because the manufacturer claims that it is 15.9. Perfect. To find critical values, first of all, we have to use chi-square table. And also, we have to do a little bit of algebra. Alpha over 2, 1 minus alpha over 2, and then we find the critical values. The degrees of freedom is 14. Then we have to find the intersection between the degrees of freedom, alpha over 2, 1 minus alpha over 2. Your alpha is equal to 5%. Very well. We take our alpha, we divide it by 2. Then 1 minus alpha over 2. We find 2 critical values. 5.629 and 26.119. Rejection regions are on the left and right hand side. Finally, you have to find your standardized test statistic, chi-squared, which is n-1, s squared over sigma squared, 15 minus 1, 21.8 over 15.9. Your test statistic is 19. Okay, 19 is between 5 and 26. It means that it's outside the rejection region. So we fail to reject the null hypothesis, and remember that the null hypothesis was your claim.